Alright, in this lesson we're going to expand a little bit more on chords, and we're going to look at how they also affect arcs and how we deal with some arcs. Okay? You guys have seen arcs before. You've seen them in maybe St. Louis, that's an arc, or our famous golden arches. Those are arcs too, Mickey D's. And we're going to look at a couple problems with that, and then we'll see how far we get and how much time we have at the end. So, central angle, pretty self-explanatory again, is an angle whose vertex is, you guessed it, at the center of the circle. So angle AZI is a central angle here. The measure of the central angle is the same as its intercepted arc, meaning where that intercepts this circle at AI, this angle, say it's 40 degrees, this arc measure is 40 degrees. Now, circles are always measured in degrees. There are 360 degrees in a circle. So those of you who watch X Games or maybe the Olympics, if you spin around one time, that's 360 degrees. If you spin around a half a turn, that's 180. So there's 360 degrees in every circle that we ever talk about. And so, again, if this central angle is 40 degrees, its intercepted arc right here is going to be 40 degrees as well. It's the same. Okay, so again, an arc is a piece of the edge of a circle, if you want to think of it like that. A minor arc is less than 180 degrees. A major arc, you guessed it, is more than 180 degrees. And then when it's exactly 180, we call that a semicircle. So some of you might have thought semicircle is just any part of a circle, but it's exactly half of a circle. Okay, so we're going to use that as we move forward. These problems are going to take you way back to first and second chapter at the beginning of the year. First one we're going to talk about is arc addition postulate. Basically, little plus little equals big. Here we go again with that, except for now it's curved and instead of just straight lines. So, measure of AB plus the measure of BC equals the measure of AC. AB plus BC equals the whole thing. So let's say this is 3, this is 4, the whole thing would be 7. Obviously, we're going to look at more challenging problems than that, but that's the main idea. Speaking of more challenging, let's look at this first problem. These take some time. Okay, and you want to make sure you get X right because that's going to affect every angle after that. So given circle T, and this is probably going to take a couple minutes, and feel free to pause and work ahead. If you think you know how to do it, more power to you. Measure DE is 3x plus 15. The measure of EL from here to here is 5x minus 9. And the measure of DL, so the whole thing, oops, cut right over it, is 94 degrees. Okay, first step on these problems is going to be finding x. So, you guys are probably thinking about how to do that. Pretty simple idea, little plus little equals big. In other words, 3x plus 15 plus 5x minus 9 equals 94. Combine like terms and solve for x. So that's going to be, what, 88? So x is 11. So x is 11. Now to go find everything else, you're just going to plug it back in. So if we need to find DE, we're going to go ahead and plug that right in. So we're going to have 3 times 11 is 33. Plus 15, that's going to get you 48 degrees. For EL, that's my blue arc there. Plug it in. 5 times 11 is 55. 55 minus 9 is 46 degrees. You can check yourself right here. Not physically, I mean check what you're doing on your paper. 48 plus 46 is at 94. Yep, so I know my x was right. I know I'm doing this problem right, so I'm going to keep on going. Measure of LZ. Okay, now you got to think a little bit. LZ, we don't really know. But we do know that DZ, going around the entire arc there, is 180 degrees. That created a semicircle. So to figure out LZ, this is where we're going to go ahead and say, okay, 180 minus 94 to get that leftover of, that's going to come out to 86 degrees. DEO, keep going now. Look at what we have here. You guys have seen this before. Hopefully you're thinking in your head. vertical angles. So these are going to be the exact same measures there. So that's 48 degrees from there to there. And let's go ahead and put that in the entire thing now. DEO going all the way around from D to E to O. So we have 94 plus 86, or you can think of it as 180 plus 48 is going to give us 228 degrees. DTO, okay, now we just have the leftover. So we want to do 360 minus what we just did. So 360 minus 228, so that's going to give us, let's see, 360 minus 228, 132 degrees. So this is going to be left over right here from this to this. So again, just plug in. You got to think about it. Take your time on you as you go through these, but really not too bad there. So if that's 132 degrees again, so is this. That's the angle we were trying to find, not the arc. LTO, so angle L to T to O, which would be L from there to the center to O. That central angle, lastly, is going to be 86 plus 48. Or you're going to get 134 degrees for your arc there. Because that means this is 134 degrees as well. Okay. So again, central angles is the same as the arc. Work from there. Okay, little plus little equals big. A couple other things about our arcs and our chords. Again, congruent arcs, it's a pretty simple idea. They're arcs that have the same measure. In a circle or congruent circles, if two arcs are congruent, then their chords with an H and central angles are also congruent. If one of those three things is true, then the other two are automatically true. So if arcs have the same measure, then their chords and central angles are congruent. If the central angles are congruent, then the chords and the arcs are congruent. So basically, if this is congruent, so is this and so is that. So that would be congruent to that. This is what we'd have here. Okay, so we're going to use it a couple spots here. First one, if you guys still need a copy of that, I'll leave that right there. Find FR. So we want to know what FR is. The only way we can find out what FR is if we know what X is. We can see that arc FR is congruent to arc GO, which means then, based on what we just said, that these two chords are congruent. So you guys see an X squared. Good thing we know how to handle that. X squared minus 5X equals 20 minus 6X. So we have X squared, add 6, subtract 20. So we have plus X minus 20 equals 0. So X plus some number, X minus some number equals 0. It's a negative product. If it's a 1x that we need to get up to, we need to add up to 1 and multiply to negative 20. That's a positive 4. Negative 20, so x minus 4 equals 0. X plus 5 equals 0. X equals 4. X equals negative 5. I guess I shouldn't have boxed that in yet. Let's go ahead and get rid of that. Let's check them both. X equals 4, so let's do that first. We have 16. 4 times 4, or 4 squared is 16, minus 20 is going to give you a negative 4. Whoa, we have a negative when we used a positive number. That can happen. That doesn't work. Try negative. Negative 5 squared is 25. 25 plus 25 will give you 50, because that's a negative 5 times negative 5. So that works there. Check it over in your other spot. 20 minus 6x, or 20 minus 6 times negative 5, that would be 20 plus 30, that would be 50. So again, you can always check them, you always need to check them, and sometimes both work, sometimes one works, always check. And number 3, TA is an angle bisector. Okay, so TA this guy right here is an angle bisector. Those angles have now become congruent, which means that chord's congruent, which means that arc is congruent. So we just found out a whole lot of information. And we're going to want to find out what ATD is. Okay, so we'll call ATD over here, we'll call that Y. We want to know what that angle is. Can't do that until we know what its arc measure is. So we know those angles are, or I'm sorry, those arcs are congruent. So again, we're going to go ahead and set them equal to each other. Yes, we're going to deal with a fraction. That's okay. Don't panic. Subtract 2/3 x from both sides. Off to the side here, let's do a little review. 2 minus 2/3. Only way we can do that is if we put this over 1. It's not like multiplication. You can't multiply straight across. You need a common denominator. The way we can do that is multiply top and bottom by 3. So it's really 6 over 3 minus 2 over 3, or we would say 4/3 is our answer. So 4/3 x minus 113 equals 7, plus 113, 4/3 x equals 120. 4/3 times x, only way to get rid of that is to divide 4/3. We never divide a fraction, instead we multiply by the reciprocal. That cancels. Multiply by the reciprocal. Here's a little multiplication one. So we have multiplication versus where we had that subtraction. Put it over 1, cross multiply. Or actually I shouldn't say cross, multiply across the top and across the bottom. So we have 360 on top, 4 on the bottom, or x is 90. Now that's just x. We're going to use that and plug it into our arc. So 2/3 of 90, or 2/3 times 90 plus 7. So that's 2 times 9 is 180. 3 times 1 is 3. 180 divided by 3 is 60. Plus 7 equals 67 degrees. So and that's going to be this. So there's that 67 degrees, which means that is also the measure of angle ATD. Should just box that in there. Okay. So again, have to sift around through your information a little bit, but you get back to that answer. Last one, and these are probably my favorite, although they can be a little bit tricky sometimes, but I do like these problems. You guys know I don't like everything I teach, but I do like these. If a radius or diameter bisects a chord, then it is going to be perpendicular to the chord. Which makes sense because chord's going straight across, radius somewhere is going to intersect that at a right angle. Note that 2 congruent right triangles then are formed. If we extend this here, extend that there, allowing the use of our favorite theorem, the Pythagorean theorem. You can call it the P theorem if you can't pronounce that, but then people might wonder what you're doing. Alright, first one we're going to look at, I'll keep that up there for you guys to refer back to. Find AB. Can't find AB because we can't really work with this unless we draw in that radius here, so I'll just make that a solid line, might be easier. And you guys know anytime we're using this, and again we want to find AB, the only way we can do that is if we find part of it first. So let's work on that. We have one side, we know the one side's 8. The other side's a radius. Well, again, as I said before, your radius appears anywhere. So you can have it here, here. The radius, if you look, is 8 plus the 9, or 17 everywhere. We want it down here. Now it becomes 8 squared plus x squared equals 17 squared. So 64 plus x squared equals 17 squared is going to be 289. I hope. Yeah, that's got to be right. X squared equals 225. Take your square root. X is 15. So x is 15. Put it back in. Always answer the question. So AB is then going to be double that, or 30. These are probably going to be the toughest for you guys. You have to draw the picture. Now it's going to look like pretty much what we just did, but again, they are a little bit tougher. So a 40 centimeter chord is 15 centimeters away from the center of the circle. What is the radius? Okay, so give yourself a nice big picture to work with. Don't make fun of my circles. We know we have a center, and we know we have a chord. Always draw that chord at the bottom. That's probably going to be the easiest for you. We know a chord is 15 centimeters away from the center. So this is 15. The chord we already said is 40. I put that there for a reason. What is the radius? So we want to know, working on either side, what's the radius? Okay. So this is a radius, this is a radius. We can work on either spot. Well, if the chord is 40, we know it's been divided in half now, or 20 and 20. So there's our setup. 15 squared plus 20 squared equals x squared. Hypotenuse is always across from that 90. 225 plus 400 equals x squared. 625 equals x squared. And that's going to be the square root of 625 is 25. And there is our radius. We'll call it 25 centimeters. Okay, because we are given a unit. So again, a little tricky, but just draw your picture if you need to, and then again make a right triangle in there. We're going to find that happening a lot, and I know you guys prefer Pythagorean theorem. Let's see, we have, maybe we'll do one or two more. Find KD, not Kevin Durant. So we're going to go ahead and mark whatever we want to find. We want to find that whole thing x. Okay, we only can do that by finding half of it first. Okay, so we're going to call maybe this y. You can work either spot you want. The radius is 34 everywhere, so it's 34 here. It's 34 there, which means we have two sides of a triangle that are labeled 34 and y. To figure out the other part, 34 minus 18, this is going to be a 16 right in there. So it becomes y squared plus 16 squared equals 34 squared. So 16 squared, that's one we've seen a bunch. It's going to be 256. 34 squared, we haven't seen a bunch. I needed some help. 1156. So y squared equals 900. That works out nicely. Y is 30. I put y there for a reason because we wanted KD. KD is the entire thing, or 60. So you got to be careful with that, but everything else is pretty simple with your Pythagorean theorem. Alright, last one before I sign off for the day. Find the length of the radius given AB is 12. So again, draw in your Pythagorean theorem, set up your right triangle. The radius is 12, so it's 12 here. I was telling you that this length from the center to the chord is 8. Okay, so we need to find out find the length of the radius, given that AB is 12, not the radius is 12. So we want to find out what this radius is here, over here. We know that center to the chord is 8. We know the bottom, if the whole thing is 12, this has got to be 6. So again, pretty simple idea. 8 squared plus 6 squared equals x squared. 64 plus 36. I love the way this is working out. Anytime we don't have to do our factor tree, it saves us time. Time is money. Peace.